everyone. Today we are going to look at how to find the equation from a graph of a cubic function. Let's get started. First, look at the start equation. There are three different graphs. You can see the first one and the third one. They have the shape of climbing up a hill, and both of them have a point of inflection. And then for this question, the corresponding rule is provided. For part A, it is transformational form, and then we can just use the information provided to determine the corresponding values of A, H, and K. For example, the point of inflection is 3, 2. It means H is equal to 3 and K is equal to 2. Therefore, we can write down the expression in this way. Now, we only have to determine the value of A. Now, we are going to use the y-intercept, -25. It tells us when x equals 0 and y is -25. We'll just substitute this point into the function. We will have A equals +1. It is consistent with the graph because the graph is climbing up a hill. It tells us the coefficient of x cubed should be positive. Then we look at part C first. Part C is just the dilated of the basic function y equals x cubed. And in order to determine the value of A, we can predict A is positive as well because the graph is climbing up a hill. And then which point we are going to select to determine the value of A. Here, 0, 0 will not help us determine it because this information is provided in the form already. It tells us that the point of inflection is 0, 0. It means H is 0, K is 0. Then in order to determine the value of A, you can use the point 1, 5 or the other point -1, -5. We are going to substitute the point 1, 5 to determine the value of A. Then y is equal to 5, A and times 1 cubed is just 1. Therefore, A value is equal to number 5. It is consistent with our prediction that A is positive. Now let's look at part B. The shape is different from the other two because it is climbing up double hills. And we know one x-intercept at the origin, but the other x-intercept is not provided. Then how we are going to determine the unknown value of A and B in this function? Then we can select the point 1, 5 and another point -3, -1 to determine A and B. Now a question is, will it be possible for us to use 0, 0 to determine A and B? No, because if you substitute y by 0 and x by 0 as well, then we will not have useful information about A and B. We will need the point 1, 5 and the point -3, -1 to get the equation. And using these two equations to get the value of A and B. Based on this question, we know if we are provided with the rule of the function, it will be pretty easy to determine the value of the unknown constants. But we will encounter many questions that the basic rule is not provided. In this example, we can see the graphs, but the rules are not provided. Then we are going to determine the rules in this way. For part A, it is climbing down double hills. If it is climbing down double hills, then the coefficient of x cubed will be negative. It means we are going to do in this way. A is negative, and we see x-intercepts, so 3 x-intercepts, and it will tell us 3 linear factors. And for the first one, x equal -1. We will use it to create the factor x plus 1. And then for the x-intercept x equals 2, we will get the linear factor x minus 2. For x-intercept 4, the linear factor is x minus 4. Then in order to determine the value of A, we are going to use one more piece of information, which is a y-intercept. Y-intercept tells us the value of y when x equals 0. Therefore, just substitute this point into the equation, and we will have -8 equals a times 1 times -2 times -4. Then we will have positive 8a equals -8. Therefore, a is -1. It means the function is like this, and the value of a is consistent with our prediction, which is negative. Now let's look at part B. For part B, the graph is climbing up double hills. It means the coefficient of x cubed must be positive. And then we are going to use the x-intercepts to determine the shape. For x-intercept -3, so it changes signs to left and right, then we will have the linear factor x plus 3. Because the graph cuts the x-axis at this point. And then one more x-intercept is 2/3. But this one, but the sign does not change to the left and right, so both are positive. Then we will have a repeated factor x minus 2/3 and then squared. Then we only have to determine the value of a, then the sign, find one more piece of information from the graph. Here we see the y-intercept is 6. It tells us the point 0.6 is on the graph. Substitute this point into the function, then we will have a times 3 times, so here when x is equal to 0, then this factor will become 4/9 because the power is 2. Therefore, we can solve it to get the value of a, which is 18/4. It is 9/2, or 2.5. This one is part B. Now let's look at part C. The graph is climbing down a hill, and there is a flat point, which is a point of inflection, and we can see the coordinates are -1, +2. So point of inflection. Therefore, we are going to use the transformational form to determine the rule. Let y be a times x minus h cubed plus k, and the value of h is equal to -1 and k is equal to 2. We substitute the point of inflection. We will have y equals a times x plus 1 all cubed, then plus k. K is equal to 2. Then we are going to use one more point to determine the value of a, and we can predict a is negative because the graph is climbing down here. For another piece of information, we are going to use 1, -2. It means the y value is -2 and x is equal to 1. Now we will have 2 cubed plus 2. Then we can solve the value of a, which is equal to -4/8, which means it is -1/2. Done. Take this opportunity to recall the 3 basic shapes of cubic graph functions. If we have the shape of climbing up double hills, then generally we use the factorized form. And then if we have the shape of climbing up a hill with one flat point, which is point of inflection, then we are going to use the transformational form, and the point inflection will help us determine the value of h and k. When the shape is climbing up a hill, but without any flat points, then we can use the factorized form, use the x-intercept to determine the linear factor, and the other factor is a quadratic one, and then we are going to use other information to determine the quadratic factor. Also, it is possible to use the general form of a cubic function when we have this type of graph. At example 2, for part A, the graph is climbing down double hills. Therefore, we are going to use factorized form. And looking at the number of x-intercepts, there are 3. Therefore, we can let the function be a times the first x-intercept -2 will be converted to the first linear factor x plus 2. Then for this, the x-intercept is equal to 0 and the corresponding factor is x. For the x-intercept 2, the corresponding linear factor will be x minus 2. And we can predict the value of a is negative because the graph is climbing down double hills. Then we are going to use another point which is provided on the diagram, which is 1, 1. Substitute this point into the function to determine the value of a, and we are going to see y is replaced by 1 and x is replaced by 1 as well. Then we will have 3 times 1 times -1. Therefore, we will have -3a equals 1. It means a is equal to -1/3. This result is consistent with our prediction, a less than 0. Then the final answer can be written as y equals -1/3 times x plus 2 times x minus 2. Done. At part B, the basic shape is climbing up a hill. For this shape, there are 2 cases. If there is a stationary point of infraction, then it should be in the transformation form. But the question gives a hint that the graph is not in the transformation form, and it means we are going to use shape 3 to determine it. Therefore, we are going to use factorized form first. Here, the x-intercept is 0. It means we can have a factor x, and another factor is a quadratic one. We are going to use ax squared plus bx plus c. As the graph is climbing up a hill, then we will predict a is positive. Then in order to determine the value of a, b, and c, we are going to substitute the other 3 points to obtain 3 equations to solve a, b, c. By substituting 2, 3, y value is 3 and x value is 2, then we will have 3 equals 2 times 4a plus 2b plus c. And then for the point 1 and 0.75, the y value is 0.75 and the x value is 1. It means 1 times a plus b plus c. And the third equation will be obtained by substituting the point negative to -3. Y value is -3 and x value is -2. And we will have 4a minus b and plus c. Then for these 3 equations, we can solve by ourselves, or we are going to use the graphing calculator to get the answer. I will leave this one to you. This one is the first idea. For this question, we can also have the second idea by introducing the function as the general form. It means y is defined as ax cubed plus bx squared plus cx plus d. And then in order to determine the values of a, b, c, d, we will need 4 equations. The x-intercept 0 will be used to create one more equation. It means we are going to substitute 0, 0 into the function. We will have 0 equals d. And then the other 3 equations are similar to the above idea. That's all for example 2. Look at example 3, which is a multiple choice question. And then we are going to select the accurate answer from the options. First, look at the graph. It has the shape of climbing down double hills. Therefore, we can use the factorized form to express this function. And then the graph cuts the x-axis at x equals a and touches the x-axis at x equals b. It means for x minus b, this factor it will be repeated, and we will have x minus b squared. And then for the x-intercept a, it will tell us the factor x minus a. then in this case we can see B is wrong. And similarly, exclude C as well, because the fact should be x minus B. And also E will not be the accurate answer. Then we're going to look at A and D. So they have the same repeated factor, and the main difference is that x minus A or A minus x. Actually, the graph is climbing down double hills, then the coefficient of x cubed should be negative. Therefore, we can write down the function in this way. Only D shows the coefficient of x cubed is negative, because for this expression we are going to put negative sign outside. Then it will be the shape of climbing down double hills. Therefore, the accurate answer should be D. Let's do a quick quiz. There are 9 graphs. We can divide them into 2 groups. This graph, it has the shape of climbing down a hill. Now we can use the transformational form because there is a point of inflection here. And then the other graphs, they are all having climbing up or down double hills. Then we can use the factorized form to determine the rule. And we're going to do in this way. First, do with question G. It is climbing down a hill. Then the coefficient of x cubed is negative. It's our prediction. And then we will let the function be y equals a times x minus something cubed plus the value of k. Then this one we use the point of inflection, which has the x coordinate to y coordinate 0. It means the value of h is equal to 2 and k is equal to 0. Then we will have x minus 2 all cubed plus 0. And then in order to determine the value of a, just use another given point, which is y-intercept. It tells us the point 0, 1 is on the graph. Substitute this point into the equation. Then we will have the value of a, which is negative 1 out of 8. Question A, the graph is climbing up a hill. The main trend is up, and there are 3 x-intercepts. Therefore, we use factorized form, and A is positive. Then the linear factors will be x plus 1, x minus 2, x minus 3. And A is positive. And in order to determine this value of A, just use y-intercept. So the remaining part left to you. Then for part B, it is climbing up a hill as well. There are only 2 x-intercepts. The graph cuts x-axis at x equals negative 1. Therefore, there is a linear factor x plus 1. But the graph touches x-axis at x equals 3. It means we can create the factor x minus 3, which is a repeated factor. Same, the value of A determined by the y-intercept line. Then for part C, this one, the graph is climbing up a hill as well. Then A value should be positive. Then there are 3 x-intercepts. Then we are going to use them to get the factorized form. A times x plus 4 times x plus 2 times x minus 1. Then for D, the graph is climbing down a hill. There are 3 x-intercepts. Then we are going to use the factorized form as well. A times x plus 3 times x plus a half times x minus a half. And A is a negative value. It will be determined by the y-intercept 6. And for E, the graph is climbing up a hill. The main trend is up. Therefore, A is positive. And there are 2 x-intercepts. Negative 4 is a repeated one. Therefore, the equation can be A times x plus 4, this one the repeated factor, then times x minus 3. Then for F, the main trend is climbing up here. the coefficient of A should be positive, and there are 3 distinct x-intercepts. Then the equation is y equals A times x plus 5 times x plus 2. Third factor is x minus 5. Then we are going to look at h. For h, the graph is climbing up a hill. Then y is equal to A times x plus 4. This one is the linear term because the graph cuts x at this point. Then we will have the repeated term x minus 3. And then for this one, A is positive as well. Finally, we have I. For I, the graph is climbing down, therefore A should be negative. And there are 3 distinct x-intercepts, and the 3 linear factors will be x plus 3, x plus 2, and then x plus half. And the corresponding y-intercept is negative 12. Use point 0, negative 12 to determine the unknown value of A. You may have already found that the key step is to determine the appropriate form of the rule based on the shape of the graph. That's all for today's content. Thank you very much for watching. I will see you next time. Bye.